Okay, hope everybody had a good weekend. This is the final week of the 6 weeks, so if you hadn't already noticed up on the board, remember the deadlines for the final two retakes are going to be Thursday morning by 8:05. That way, when I come in on Friday, I just want to be able to submit all the grades and be done with the current grading period. So the only retakes we still have available are going to be the rational inequality exit ticket from early last week. You can still do that, or the other one, the main one, which is going to be what? The second exam from last Thursday. Okay, so if you have anything lower than an 80 and you want to bring those up to an 80, you can come on in, ask me some questions, or just get right to it. I've had several people come in already this morning, so you've got 3 mornings left. All right, if you have any questions. Not a whole lot going on this week. We're going to go ahead. Hopefully, we're going to be able to use this week to get through our final 2 review sections. We're going to be talking about composition of functions for the first couple of days. Then we'll move over into inverses of functions. And then next week, we should finally be able to start trigonometry, the unit that's going to pretty much encompass everything we do for the rest of the school year. Okay. They mentioned the pep rally Friday during 8th period. As far as drills go, our next drill is going to be next Friday. We have a hold drill during 7th period. And I don't believe we have our next fire drill until October 11th. So that's still a couple weeks out. All right. Any questions about what's going to be happening the final week? Okay, well, let's get into compositions of functions. We are going to be looking at this in 3 different ways in this lesson, numerically, graphically, and analytically. So when we say numerically, we're talking about a table. In fact, this first table right here, where you have the 4 rows, x, f of x, g of x, and h of x, this is the combination of 3 different tables. Okay, 3 different functions using the same values of x. Now, we're going to go ahead and take a few of these examples before we get to the composition, just to make sure that we feel comfortable finding the appropriate value for the function notation. Okay, let's start with the first one. I want to simplify this expression beginning with -3 times h of 0. Well, if I were to ask you, okay, I want h of 0. Okay, we're inputting a value of x, 0. So can anybody tell me what the corresponding output should be? Yeah, it's going to be 2. So I'm going to go to the appropriate row, function h, and I'm going to find the cell that corresponds when I have that value of x I'm looking for. So -3 h of 0 would be -3 times 2, because h of 0 is equal to 2, times, now I want to do the same thing for g of 3. So I go to the appropriate row. When x is -3, I get what? -2. And then now I just want to take a product of the expression that I have. What would that be? 12. That's it. Okay. All right, so take a few seconds if you haven't already done so. Try B. Try to get me the value for the expression 2 times g of -1 divided by f of -2. Okay. All right, let's start with Jake today. Jake, what's the value of this expression for B? He has not done it yet. Emma, can you help him out? She can help him out. Connor?
14 thirds.
14 thirds. There we go. That is exactly right. Because the first thing I'm looking for is g of -1. So function g, when x is -1, that's going to be 7. So I'm going to double that. And then I'm dividing it by f of -2. So I'm going to go function f when x is -2, and that provides me 3. So there is the 14 thirds we're looking for. Okay, now C, again, is not a composition of functions, just practicing, making sure you can find the correct values from the table. Okay, would anybody like to take a look at C? You would? Okay, let's do it. So somebody help me out here. The first thing I need is h of -2. All right, so function h when x is -2 should be a what? -1. Plus, now I'm going to have 3 times the output value for g of -1. So I'm going to go to the appropriate row, g. When x is -1, this will give me 7. So it looks like I have -1 plus 21, which gives me 20. There we go. Is there anybody having trouble determining the output value using the table? Anybody confused? Okay. So now let's go ahead and start looking at compositions of functions. This is where you evaluate one function inside of another. You always want to begin with the innermost function, and the one thing I'm going to continue to say today, the output of the inside function should belong to the domain of the outside function. That means you can only continue this process if the output value you get is an x value that belongs to the outside. So let me explain what I mean by that. We're not going to worry about D. That's actually not a composition as we're looking at it right now. That would have me perform an operation. So the first one we actually have is h of f of 2. Now this is just one way that the problem could be presented to you. Different resources, different teachers may go ahead and write it like this. Okay, both of these are equivalent. That little circle just means composition. So h composed with f of 2, that's equivalent to just using all those parentheses. Okay, so what would I want to evaluate first, function h or f? F. Always start with the innermost function. So I want to know f of 2. So just like we did before, I'm going to go to the appropriate row, the appropriate x value. So I get what? 3. Now here's the thing. If I were just to ask you like we did before, okay, f of 2, I know that's going to be 3. Given the x value of 2, we got an output, a y value of 3. So whatever function f looks like, I know that an ordered pair 2, 3 belongs to that function, right? But now here's what we're going to do. The output, the answer to the inside function, now becomes the input for the next function. So this y value is now going to become an x, and I'm going to plug him into the very next function. So now I'm looking for h of 3. Okay, so I want h of 3. So again, I'm going to go to the appropriate row and column. H of 3 would give me what? -1. So the value of the composition would be -1. Okay. And if this is one of those where you can do it, mentally and write your final answer, or if you need to do as I did here, go ahead and write the innermost function, get the value, and then show the substitution, perfectly fine. Okay, I've got all kinds of students doing those today. Okay, so let's try f. G of f of -3. All right, so where am I going to start? F of -3. Okay, that's my innermost function. So function f when x is -3 will give me 0, and some people might like to go ahead and just put a little arrow over the innermost function, and in this case, just put 0. Just actually show that that's what f of -3 becomes. Personally, I like to go ahead and write it out, g of 0. Okay. I plug that output directly into the next function. What's g of 0? -2. That's it. That's composition of functions. Anybody having a hard time? Okay. All right. Well, let's take a look at a few more. Now, G, H, and I, those are just additional compositions. But you'll notice it starts to change with J, K, and L. So we'll get to those in just a second. Somebody choose G, H, or I. Eli, what do you think? I. Okay, so we want f of h of 1. So I'm going to come back over here where I can see the table. Let me erase this. So I'm looking for f, was it G, F or G? Let's see, what was that? It was f of h of 1, excuse me. F of h of 1. Okay. So let's do the same thing. What's h of 1? Okay, that is -3. So I'm going to plug that directly into the next function. So now I'm looking for f of -3, which will give me 0. Okay. Now, not every class today has done every single one of these examples. In fact, only second period so far has decided to go ahead and do every one of these. So we just did I. Do we feel we need more practice on G and H, or do we have the idea? Do we feel comfortable? Would anybody like to do those extra examples? Okay. All right. Well, what's the difference between the ones we've been looking at in J, K, and L? Yeah, you just have an extra composition. Here you have a composition of 3 functions. And really, there's no limit to the number of times you could compose a function with others, as long as the original rule stands, that the output for the inside function, that y value belongs to the domain of the next function. Because remember, it becomes an x value, and it's going to be evaluated in another one. Okay, so let's try j. H of g of f of 2. H of g of f of 2. Okay, let me erase this right here. So where would I start? Yeah, f of 2, the innermost function. So f of 2, okay, looking at function f when x is 2, that gives me what? 3. So now I have h of g of 3. The output, the answer I got for f of 2 gave me 3. I'm going to plug that into the very next function, g. Okay, so now he's the innermost function, and we just continue. What's g of 3? That gives me negative 3. So I'm going to go ahead and plug the negative 3 directly into my last function, h, which gives me what? 1/2. Okay, so the value of the composition, h of g of f of 2, ultimately ended up being 1/2. Any questions? Okay. Well, let's try the next two. Take about 30, 40 seconds. If you haven't already done so, try K and L. G of H of F, and then G of F of G. And let's see if we can get those final answers. Then we'll have a couple of equation problems to look at. G of H of F of -1. All right, so let's try presumption. What'd you get for K? -2. Do you guys agree? That's perfect. Anybody want me to walk through that process? Show how we got that. Okay. Clarissa, can you help me out with L? Negative what? -3. Perfect. Again, anybody want me to run through the composition to show that she's correct? Feeling pretty good? Easy, right? Okay. Well, let's try M. If K of X equals 2X plus 10, then for what value or values of X is H of X equal to F of G of H of -1? Okay, well, let's start with the composition. Okay. William, can you help me out with that? What is F of G of H of -1?
That would be negative.
Okay, so this guy right here is -4. Okay. Again, any takers? Anybody want me to run through the composition, showing how we got that? Okay. Well, we know that this composition is equal to K of X, so in order to create my equation, we're going to set the value of the composition equal to the function K. So K of X, 2X plus 10 equals the composition, which we got -4. And see, now it's just a simple two-step equation. In fact, what is X? There we go. If you go ahead and subtract over the 10, divide by 2, X equals -7. Perfect, 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 perfect. Okay, we ready for one on our own? Let's try N. If P of X equals the absolute value of 2X minus 3, then for what value or values of X, P of X equal to F of G of -2? All right. And the reason I'm having you do it this way, there are several people throughout the classes today who have forgotten one crucial item when dealing with this problem. Let's see if some folks in here can figure out what I'm referring to. Excuse me. And while you guys are wrapping up this problem, I'm talking to my superintendent scholar students. Don't forget this weekend is our first what?
Verbal.
First Saturday that we're going to meet. We're doing the verbal. You're only going to be taking sections 1 and 2, and then you'll be able to answer questions over those. And then I believe it's 2 weeks from Saturday when you'll take 3 and 4. And that's when I'll play a much more important role. I'm basically going to be there on Saturday. All right. Okay, so let's see here. Sandra, help me out. We need to start with the composition. F of g of -2. What'd you get?
4.
Okay, 4. There we go. So I'm going to set 4 equal to, okay, function p, the absolute value of 2x minus 3. By show of hands, how many people believe they have the answer or answers that makes this true? Okay. What'd you get, Eli?
7 halves and -1/2.
That's exactly right. There are 2 answers you should be finding here. 7/2 and a -1/2. How many people got the 2 answers? Fantastic, fantastic. Okay. Let me just go ahead and elaborate because not everybody's hand went up. What is absolute value actually going to do for me? It's always going to make anything positive because we're talking about the distance from 0 on a number line, right? Okay, so for example, if you're solving an absolute value equation, you want to create 2 equations. All right, so first I'm going to say 2x minus 3. The expression contained in the bars here is equal to my constant, but then I'm also going to go ahead and say 2x minus 3 is equal to the opposite of that constant. Because when you're dealing with absolute value, you're correct. It's always going to provide a positive result. But there are 2 different values that I can take the absolute value of to get the same answer. In fact, if I took the absolute value of 4, it would give me 4. But if I took the absolute value of -4, it would give me 4 as well. That's why we're having to take the expression and set it equal to both plus and minus 4. What values of x are going to make this correct? Is everybody okay with that? Okay. And when you solve it, you do get 7/2 and -1/2. Good. Good, 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 good. All right. All right, so any questions on the table? Composition of functions. Everybody's okay with the table? Okay. Well, now let's look at composition of functions graphically. Okay. So we have functions f and g. Again, several examples, not going into the composition just yet. We're just going to talk about, again, how to find the appropriate corresponding value. So let's see here. First expression says -3 times f of 2. All right, so function f, I definitely want to go to graph f, but how do I go ahead and find the corresponding value? What do I do here? Look at the x, okay. So I know 2 is right here. So now, depending on if the graph is above or below the given value of x, okay, you go to it, and then immediately to the corresponding y value. So I know f of 2 here is 2. It's providing me the same information as the previous page. We just see the graph this time instead of it being listed in a table. Okay, so now I want to add that to g of -3. So I know I'm going to go over to function g when x is -3, but in this case, the graph is below that x, so I'm going to go down and then straight over to the y-axis as soon as I hit the graph. So what's g of -3? -2. All right, so ultimately, what's my answer? -8. There we go, -6 minus 2. All right. Okay, let's go ahead and try one more of those. We need g of 3 minus f of -1. Okay, so Laura, help me out. What do you say is the value for g of 3? G of 3 is what? We're starting B. So first I'm looking for g of 3. Function g when x is 3. Close. We just don't need one item. There you go, positive 1. Okay. When x is 3 right here, go straight up. The graph is above. Okay. Minus, and Andrew, can you help me out? I need f of negative 1. Okay. When x is negative 1 in function f, negative 3. But what happens when you subtract a negative? Okay, so I should be getting 4. Okay. Good. All right. Did anybody want to go ahead and take a look at C, or are we feeling comfortable finding the corresponding values? Okay, no takers. Then onward and upward. Okay, D. This is where we start getting into my function, or composition of functions, I should say. G of f of negative 1. So it's still the same idea. Okay, the output for the inside function has to belong to the domain of the outside function. Okay, so Xavier, help me with this one. What is f of negative 1? In fact, we just got that. Okay, so f of negative 1 equals negative 3. So this output becomes the input for the next function. So now I want g of negative 3. Okay. And Will, can you help me out with that one?
Which one?
G of negative 3. We already evaluated f of negative 1.
G of negative 3, negative 2.
There we go. So the overall value of the composition, g of f of negative 1, I'm getting negative 2. Okay. All right, let's try E, f of g of 0. All right. So where am I going to start here? F or G? Okay, G. Galen, can you help me out? What's g of 0? 2. Okay, it's on the y-axis. So this is f of 2. And Natalia, can you finish that out for me? F of 2 is 2. There we go. Okay. All right, so especially once you get the idea, these start to go pretty quick. Okay, for f, g of f of negative 2. G of f of negative 2. So, Jake, I'm going to come back to you. Can you help me out with that one? F. Letter F. G of f of negative 2. Can you go ahead and give me the final answer? It is 3. Perfect. All right. Nice. All right. Now, you'll notice as we go through, this time G, H, I, and J, those are all just normal composition of two functions. Would anybody like to look at any of those four for extra practice? We feel confident. We feel comfortable? Okay. All right. Change your mind. Let me know. I would like to go ahead and look at K and L, simply because that's a composition of three functions. So let me give you a few seconds. Try K and L. See if we can come up with the final answer to those compositions. And then we will try M and N. I think somebody's phone is buzzing. Is it my phone? I don't think so. So K, F of G of F of 1. Okay, let's see, who have I not talked to today? Fernando, what is the value for K? It is 2. There we go. Okay. And Solindra, can you help me out with L? G of F of negative 3. It is 3. Perfect. Does anybody want me to walk through either of those? Did anybody get anything different? Okay, Philip, what'd you get? Okay, let's take a look at that. G of F of negative 3. G of f of negative 3. So G of f of negative 3. All right, so I'm going to start with the innermost function, so f of negative 3. All right. So function f negative 3 will give me what? Okay, so it looks like f of negative 3 is 1. Would everybody agree? G of 1. Okay, so the output for this function f becomes the input for function g. So now I want g of 1. Okay, so what's g of 1 give me? Negative 1. Okay, and then g of negative 1. Okay, we're still in the same function, so we do end up with 3. Philip, do you see where we made our mistake? Hmm. You ended up getting a negative 2? Okay. All right. Any other questions? Everybody's okay? Okay. You guys are a little too excited today. I think you need to compose yourselves. See, that was a joke because we're talking about composition. Okay, M. If h of x equals x squared minus x, then for what value or values of x is h of x equal to g of f of 1? Okay, so let's get to some audience participation. Who would like to come on up and help me with this problem here? Natalia? Or Philip? So actually, two people raised their hand this time. Whoever wants to come up. Okay, so Natalia is coming up and helping me with M. All right. So h of x equals x squared minus x.
Okay, so for this, I got. Do you want me to write it out or you want to?
Okay.
So.
Oh, but I forgot. Would you like the headphones?
Oh, no, I'm good, but hey guys.
There you go. Okay.
F of 1 has 0.
Okay. So f of 1 is 0. So now we're looking for g of 0.
Which equals 2.
Okay.
So now you have x squared. Okay, we're not going to go there. You have x squared minus x equals 2.
Okay, because it tells me h of x equals g of f of 1. Okay.
So now you're going to turn that into a quadratic.
Okay.
And just factor it. And the
There you go.
factors that I got were.
No? Oh. There you go. Okay. Okay, so she's going to go ahead and factor it.
2.
So x minus 2. Okay, now that equals 0. Oh, because you moved the 2 over, so it would equal 0. But you're fine. You're fine.
Sorry, guys.
You're fine.
Okay,
X equals negative 1. That's the, I don't know, what do you call that, the symbol for and? What's it called? Ampersand? Okay. There you go. So negative 1 and 2. Perfect. Okay, good. Good, good, good. All right. Okay, any questions on M? Now remember, factoring was probably the best way to go because it was a very simple trinomial, but what are some other methods we've talked about if you wanted to use them? Quadratic formula. What's that, Will? Well, you got a big smile on your face when you said that. Do you like completing the square?
Oh, I like completing the square, but most people don't.
Okay, all right. So completing the square is also another one, yes. It's not typically a popular one, yeah. Okay. Now, Philip, I saw your hand was up on that previous one. Would you like to do N? Okay. Sure. So if P of x equals 3 times the absolute value of x minus 2, then for what value or values of x is P of x equal to f of g of negative 2? Okay. Did you need me to go back to the graphs, or were you okay?
Can you go back?
Sure can. So we need f of g of negative 2. F of g of negative 2, yes, sir.
Negative 2.
Okay. Oh, taking the time. All right, so yes, sir. Oh, wait, there you go, sir. All right, thank you. All right, so f of g of negative 2, you got that to be 2? We're close.
Oh yeah, it was negative.
It was negative 2. Okay.
Thank you. So I said 3 of whatever that thing is, absolute value.
Absolute value.
X minus 2 equals to negative 2.
Uh-huh.
And then I set it up into 2 equations. Oh yeah, no. Sorry. First, you have to divide the 3, right?
Okay.
You get absolute value of x minus 2 is equal to negative 2/3. And after that, you can make your 2 equations. X minus 2 equals negative 2/3. And x minus 2 equals
Somebody help him.
2 thirds. Did I do something wrong?
There is, unfortunately, a mistake, yes, sir. What's that? Well, in order to solve the absolute value equation, he is correct. You're going to break it up into 2 equations, but why is this one different than the previous one? Sandra, you raising your hand? That's exactly right. Remember, absolute value will always give what result? A positive. So that means there's no value of x that if I take the absolute value will give me a negative 2/3. So what's that mean for the overall problem? It was a lie. There we go. There is no solution. Good. Good job.
Got it.
That's fine. That's fine. Okay. There were several students today who forgot about that. And it's really easy to forget because you get in that habit of just creating the 2 equations and moving forward. Okay, so good. So everybody's okay while there's no solution. Okay. How we doing so far? Good. All right. Well, we've looked at the table, which is considered numerically. We looked at graphically. And now we're going to look analytically, which means we actually have the equations for the different functions. So it looks like function f here, we got a quadratic, g and h are linear functions, and p is a what? Rational. Okay, and we're most familiar with that. We've spent several weeks on rational functions. Okay, so this one, we do have one example. It does kind of go out of order, so let's start with number 2. This one is not a composition. Again, it's just making sure that you're able to find the corresponding values and simplify the expression. So if I was to ask you, okay, I want f of negative 2. Well, what am I actually asking you to do? Yeah, plug in negative 2 for every x in function f. So we want to make sure to put it in the right equation. So f of negative 2 would equal negative x squared, so that's negative 2 squared, plus 3x, so plus 3 times negative 2, and then minus 5. So what does the first term become? Okay, negative 4. It would be negative. Because remember, the square is going to make it positive, but then you got this negative waiting on it. So negative 4 minus 6 minus 5. Negative what? Okay, so f of negative 2, we got negative 15, plus, now I want p of 2. So I'm going to go to function p, which is the rational, and I'm going to plug in 2. All right, so x plus 2, 2 plus 2, over x minus 3, 2 minus 3. What does this one give me? Negative 4. There we go. So p of 2 is negative 4. So what is the overall value f of negative 2 plus p of 2? Negative 19. There we go. Okay. So any questions? Everybody's okay how I did that? Okay. All right. Well, now let's go back to number 1, which is our first composition. G of h of 4. All right, let me go ahead and get this out of here. So it's the same thing. We don't have a table. We don't know what the graphs look like, but I do have the function, and we can evaluate them ourselves. So this one has a little more work than the previous ones because we're not already provided the value. But the rule still stands. The output for the inside function must be in the domain of the outside function. Okay, you're going to notice we're going to come across our first problem in just a moment. Difficulty with that. So here, do I start G or H? H. So I want to know, okay, H of 4, that's my inside function. So here's our linear. So 3 halves x minus 2 would be 3 halves times 4 minus 2, which would give me what? Okay, that would give me 6. Okay. 6 minus 2, which would be 4. There we go. Okay. So now this is the output for my inside function. So if I were to go ahead and graph this linear function here, the point 4 comma 4 would belong to it. But now I'm going to take this output, and he becomes the input for the next function. So now I have g of 4. Okay, and as long as 4 belongs to the domain of g, this is going to be perfectly fine. Okay, and g is a linear function, so they are infinitely wide. So this would just be 1 minus 2 times 4, which would ultimately give me what? Negative 7. Okay, there we go. Any questions? Okay. Would someone like to come on up and help me with number 3? Okay, Sandra? All right. So I'm trying to find the value of the composition P of g of negative 1. P of g of negative 1. Okay, so what function am I going to start with? Oh, yeah, sure.
First, gonna take the function of g.
Oh, in fact, would you like the headphones?
I don't want to.
Oh.
I figured I have to talk.
Okay. Okay. Oh.
You'd end up with plus. Yeah, it's going great. Love it. So, whoa, this is going different than I had it. Great. Okay.
So you're saying with g of negative 1 is what?
G of negative 1 is 1.
No, 1.
Okay. Then it's 3.
3. There we go.
Yay. Okay. Well, then I did a mess. Yeah. Okay. I forgot to get rid of that. Okay, so you'd have 3. And plugging 3 into this function, you'd have 3 plus 2, and then 3 minus 3. That's 0, so no solution.
That's exactly right. This is the first composition that we've come across that kind of illustrates the one idea that I keep saying. Okay. The output for the inside function must belong to the domain of the outside function. See, for g of negative 1, she got positive 3, right? Okay. That's the output for the inside function. Just like we've been doing all day, I'm now going to take this and plug it into the very next function, p. But can anybody tell me what's the domain of p based on what we've talked about with rational functions? It should go from negative infinity to what? 3 union 3 to infinity. Okay. In fact, what does 3 represent for this particular function? He's a vertical asymptote. He's a value of x that's going to make the denominator 0. So see, this output for the inside function does not belong to the domain of the outside function, which is why we weren't able to evaluate the composition. That's what I was referring to, the entire day when I keep saying that. You can only evaluate the composition if the output of the inside function belongs to the domain of the outside function. Okay, questions? Okay, so I've got 1046. That is actually as far as the other classes got. Would you like to try and push forward a little bit, or you just want to go ahead and stop for today? Okay. Philip, are you sure? I'll keep going.
I'm sure we can stop.
Sometimes peer pressure can be a good thing. Okay, we'll go ahead and stop for the day. All right. Good.